So the last thing I want to talk about today are some usage considerations to keep in the back of your mind when you use ReentrantLock. These are kind of a summary of best practices. Some of these are going to look very familiar because there are also similar issues that arise when you use semaphores, which is no accident because they're very similar locking constructs, synchronizer constructs. First and foremost, a ReentrantLock must be used in a fully bracketed way. So the thread that acquires a lock must be the one to release it. This is something that's often known as the scoped locking pattern, which was a POSA2 pattern that you can read here. I wrote this, again, about 23 or 24 years ago. And it describes this concept of acquiring a lock when you come into a critical section and having it automatically released. You can do this in Java by using a finally block. You can also do it in Java by using a synchronized method or a synchronized statement. So here's an example of using synchronized statement where the close curly brace, in effect, is what triggers the release of the intrinsic lock that's associated with this object. There's also other languages where you can do things like this. They're done in slightly different ways than they're done in Java, but nonetheless, they're still important things to be aware of. So in C++, they have this concept of a lock guard, where you come in and you automatically acquire the lock in the constructor, which is an idiom in C++ known as resource acquisition is initialization, or RAII. And then when you leave the scope in which this lock guard was defined, its destructor automatically unlocks the lock. That's a very common idiom. The ReentrantLock has recursive mutex semantics, or reentrant mutex semantics, where you start out with a lock count of 0, which means unlock. The first time you acquire this, the count goes to 1, and then at that point you can keep incrementing it over and over again by calling lock, which only increments the count. And then, of course, you need to call unlock the corresponding number of times, otherwise it'll never get released. And when it finally drops back to 0, then it goes ahead and releases the lock. That's reentrant or recursive mutex semantics. As with semaphores, ReentrantLocks can be tedious and error-prone to program because of these common traps and pitfalls. So one thing is you might grab a lock, do something that doesn't really require the lock to be held, and hold the lock for a long time, and then you're just kind of locking other threads out from doing anything useful while you have the lock held. Another problem is to acquire the lock and then forget to release it. That's a very common problem. This is why it's a good idea to get in the habit of always using unlock, using the critical section to unlock things. So I don't show that here, but a good idea is to always have the ReentrantLock have a finally block that unlocks it. Another problem is to unlock a lock you never locked. And that may seem like a crazy thing. You're like, how could that ever happen? That sure is dumb. Well, if you have code that has complicated conditional expressions in it, through one path of the code, you might not acquire it, but through another path of the code, you might release it. So it is not as hard to do as you might think at first glance. Another problem is to acquire a resource or access a resource without first acquiring the lock or after you release it. So if you forget to acquire the lock and then you go into a critical section and you make changes to something that is shared, it's shared mutable data between multiple threads, then of course chaos and insanity will ensue. This is one reason why built-in monitor objects with synchronized keywords can be a little bit more fail-safe, because putting synchronized means this happens implicitly without you having to do explicit calls to lock and unlock. But as we saw, there are reasons to use ReentrantLock because it provides more features than the locks that come with the intrinsic locks, the built-in monitor object locks with synchronized keyword. So that's the end of the usage considerations. As a general rule, these are low-level mechanisms, so it's probably a good idea to encapsulate them within monitor objects.